My name is Juliana Suarez, and today I'll be presenting my paper titled The Impact of Traffic-Related Air Pollution on Children's Brain Structure and Cognitive Development. When most people think about air pollution, they usually think about breathing problems like asthma or lung disease. However, recent research has shown that air pollution can also affect the brain, especially in children whose brains are still developing. This topic is important because millions of children around the world live near busy roads and attend schools with heavy traffic, exposing them to harmful pollution every day. Uh, Traffic-related air pollution, also known as TRAP, is made up of pollution released air from cars, trucks, and buses. Some of the most common pollutants include nitrogen dioxide, fine particle matter known as PM2.5, black carbon, and ultrafine particles. These pollutions are so small they can travel deep into the lungs and into the bloodstream, and in some cases even reach the brain. Children are especially vulnerable because their brains are growing rapidly during pregnancy, infancy, and childhood. Their bodies also breathe faster than adults and are less able to remove from harmful toxins. Because of this, long-term exposure to traffic pollution can interfere with normal brain development, known as the one of the most important studies I discussed was published by Lopez Vicente and colleagues in 2025. So the researchers used MRI brain imaging to study adolescents who had been exposed to traffic pollution over many years. Instead of only looking at brain size, they examined how different parts of the brain communicate with one another. They found that adolescents who were exposed to higher levels of pollution had changes in brain cognitivity, particularly in areas responsible for attention, memory, emotional regulation, and executive functioning. These findings suggest that pollution may affect how efficiently the brain processes information. Another study by Pojo and colleagues found similar results in younger school-aged children. Children attending schools with higher levels of traffic pollution showed altered communication between important brain networks, even though they appeared healthy and had no obvious neurological disorder. This suggests that pollution may cause subtle changes in brain development long before symptoms are noticeable. Also discussed research by Guxin and colleagues who looked at parental exposure to air pollution. Their study found that babies exposed to higher levels of air traffic pollution before birth showed differences in brain structures years later. These children also performed worse in several cognitive tests. This tells us that the effects of pollution may begin even before childbirth. These structural brain changes are reflected in children's cognitive abilities. Research by Bogsna and colleagues showed that children exposed to higher levels of fine particles experienced slower cognitive development over time. They had greater difficulty with working memory, information processing, and overall learning compared with children who were exposed to cleaner air. Similarly, Sonier and colleagues found that children attending schools in areas with more traffic pollution had reduced attention spans. Since attention is essential for learning, these small changes can accumulate over time and affect academic performances and educational success. Researchers have also identified several biological mechanisms that explain how traffic pollution affects the brain. Fine particles can trigger oxidative stress, which damages cells by producing harmful molecules called reactive oxygen species. Pollution also causes chronic inflammation throughout the body, including the brain. In addition, ultrafine particles may travel directly from the nose to the brain through olfactory nerve. These processes can interfere with normal brain development, especially during pregnancy and early childhood. Another important finding from my paper involves autism spectrum disorder. A review by Costa and colleagues conclude that traffic pollution may increase the risk of autism in children who are already genetically susceptible. While pollution is not considered the sole cause of autism, it may be one environmental factor that contributes to its developmental through inflammation and oxidative stress. Finally, my paper discusses the public health implications of these findings. Unlike many neurological risk factors, traffic-related air pollution is something that society can reduce. Communities can improve air quality by reducing vehicle emissions, expanding public transportation, increasing green spaces, planting vegetation barriers around schools, and improving school vegetation systems. Healthcare providers can also educate families about ways to reduce children's exposure, especially during pregnancy and early childhood. In conclusion, the evidence the evidence consistently shows the long-term exposure of traffic-related air pollution can affect children's brain structure, cognitive development, attention, learning, and even increase the risk of certain neurodevelopmental disorder. Protecting children from air pollution is not only important for their physical health, but also for their lifelong cognitive developmental, educational achievement, and overall quality of life. Thank you for listening.